right. So typically when I give talks, I'm in the States, but I'm in Europe. And so I'm dying to know how many of you have never used Netflix. You've not even watched it on a friend or family member's account. So show of hands. Okay, awesome. So we're going to share some context with you guys so that you understand some of what it is that we're going to be talking about when we get to the fun stuff. So we'll start just with a quick look at the company. The company is the largest provider of streaming entertainment in the world. We have 150 million members worldwide, and our international subscribers now outnumber our domestic. The company started in 1997, so 22 years ago, and at the time it was just in the States. But we rolled out to Canada in 2010, so 13 years later. And from that point forward, we had a pretty rapid international expansion. We went into South America and a few countries in the UK, and then all at once, simultaneously, we launched in 130 countries worldwide. So now, as you can see, we are, well, we're almost worldwide. We're also very popular. So even though we haven't been that international for that long, we currently account for 15% of all internet traffic. And in the US, that number is closer to a third. So sorry for your bandwidth. But it's funny to think about that because the company didn't start as a streaming service. It started as a DVD by mail service. And at the time, people said, that's never going to work. Why would I possibly go to this website and order a DVD to come in the mail and wait a couple of days when I could just go down to the video store and rent it right now? But it took off. And a few years later, they decided to venture into streaming. And again, people said, this is never going to work. You're never going to be able to reproduce the quality of experience you get on your television on a website. So despite the amazing technical challenges that they had and all the naysayers, it took off. And the company has been constantly evolving ever since. If you've not used the product, when you log in today, it might look something like this.
You are the property of Bancroft Industries. You've been provided with this body, which came equipped with military-grade neurochem and combat muscle memory.
Mr. Kovacs.
I didn't ask you to bring me back into this world.
All I ask of you is that you solve a murder.
Whose?
Mine.
This is the beginning.
So one of the things we have learned is that the best format for describing video is video. I mean, what do you think? Do you get a better sense of what that television show is about? I know I do. But it's really this constant evolution of the company has been enabled by the culture of the company. Culture of the company. So I would say there's 3 company cultures out there that are somewhat famous. Amazon with Jeff Bezos, Ray Dalio and Bridgewater, the largest hedge fund in the world, and then Netflix and Reed Hastings. And if you look at all of those companies, they all have, from the core of their DNA, really built their companies around this concept of experimentation and learning. So I want to give you an example as to why. Any Breaking Bad fans in the audience? Okay, that's more than I thought. Okay, so all of you, though, imagine for a moment that you've been asked to pick the image that is going to have the broadest appeal worldwide. So we have our first image. It is a trailer on this desolate desert background. The second image, we have a middle-aged man in his underwear with a gun and a camper with smoke streaming out of it. And then we've got this third one, which is a highly stylized image of Walter White, who is the main character in the show. So show of hands, how many of you think that the first image has the most appeal? Second image. Third image. Okay, the answer is actually number 1. I could not, for the life of you, tell you why. Like, I don't understand it. But that's just it. It turns out that we, all of us, are very, very good at predicting behaviors and what people want and like when they're exactly like us. And most people are not exactly like us, right? And so when you want to create a really large global company, you really need to have experimentation as part of the lifeblood of that company. So how do we do that? Well, I'm now going to go into the technical stuff, and I'm going to give you a high-level overview of the flow of information through the company, specifically for data. And we're going to look at just one of those pieces of information, our event stream. When I say events, I mean every single time you click play, pause, next, every time you authenticate into the service, everything you do creates an event, right? And that event is written into our streaming ingestion pipeline. We write more than 1 trillion events every single day. That data gets loaded into a raw ingestion layer inside of S3. Now, everything that you see on this slide and everything that I talk about is all taking place in the cloud. Netflix was one of the first companies to really shift to the cloud. So we have a logical, traditional 3-tiered data warehouse with untraditional technologies, and all of the data gets landed in this raw ingestion layer, and then we use a variety of tools to process it. I have Pig on here, mostly because of our legacy code. So we do still run Pig, but all of our development going forward, and has been for a while now, is in Spark. And then we aggregate and denormalize our data and load it into a reporting layer, which is then moved over to a variety of fast access storage. So this is Snowflake, Druid, some Redshift, Elasticsearch. And we use that for our data visualization tools. For everything else, we have a variety of tools for our users to use. We've built something called the Big Data Portal, which is just a landing place for the data platform, and then we support pretty much every major tool that's out there, because not all roles and not all projects are created equal. And our goal as a platform team is to enable people to be successful with data. Something else that's different about this company is that once you are hired, you have complete access to the data platform, to all the reports, everything excluding sensitive information. So in a lot of companies, you have to request specific access to a table or to a database or report. Here we say, you're an employee, and we expect that you're interested in this because there's some value to the company for you to know this information. So we're gonna make it accessible to you. Now, on the back end, we're monitoring all of that for security patterns to make sure that there's no malicious behavior here, right? But our company here, the premise is really that we want to make data accessible. So that was just a high look at the platform. We're going to drill into a little bit more of it later. But let's talk about those users, right? I like to think of users in 3 different tiers. The first one is our data producer. People that are primarily tasked with creating a table or a report or an algorithm. Then we have our data insights, people that are primarily tasked with creating some sort of insight to the business. And then finally, we have our business decision makers and our product teams, right? And so this is the flow of information and data through the company, where we have, I would say, our data producers at that lowest tier, most technical for the platform. Then we have our data insights, the people that are most closely resemble scientists. And then we have a whole bunch of everybody else at the very top. So what are they doing with that data, right? One of the business decisions that we have to make is what content to license, but mostly what content to create. We are on track to spend $15 billion on content this year alone. We are the largest content producer in the world now. So The problem for us is how do we make sure that we are serving all of our members in a way that's going to best meet their entertainment needs, right? What we've done is we've built predictive models that can, with pretty high accuracy, estimate the audience for a given title. We look at a variety of indicators such as, the genre, the talent involved with it, maybe how it's performed on other services. But we look at all of those things and we come up with an estimated size. And based upon that, we can back into a dollar amount or to an amount to pay. What works really well about this model is that it allows us to serve really niche interest while also spending a lot more money on content that has broad appeal. We also use data to personalize the experience. So this is something that a lot of people have heard about around Netflix personalization. But just to be clear, every single profile of every single of our 150 million members is completely uniquely personalized for that person. We don't create categories of taste. We actually look at what you have looked at in the past, and we try to show you content we think is going to be interesting. Why? Because the amount of content that we have, or anybody has, is going to exceed your ability to go through it, right? And we have around 60 seconds to capture your interest. Doesn't sound like a lot of time, but when you're sitting there going, next, 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 it feels like forever. So we have about 60 seconds before you decide to go spend your free time somewhere else. And we want to help you find the content that is going to be of greatest interest to you. Everything on this is personalized, so what do I mean by that? Well, this billboard at the very top, the image, well, first, the titles that we select, right? But then the images that we select as well, and even the teaser, the rows and the titles that are in the rows, the ordering of it, the images that we show you, even when you mouse over those titles, the previews, everything is personalized. Why? Because not every single show is going to appeal to you for the same reason. If you take a Stranger Things, for example, it's a show that has a little bit of mystery, some 80s nostalgia, it has a sci-fi element. And when we're trying to describe to somebody, I say describe, we're trying to show you why do we think this is appealing to you. We want to give you some indication as to why we think that content is going to appeal, right? And so if you've watched 80s shows in the past, we're probably going to use an image that's a little bit more like an 80s nostalgic image. If you like sci-fi, we're going to probably show you an image that's a little bit more sci-fi. The goal isn't to trick you. The goal is to help you quickly understand what that content is about so that you can make an informed decision. So here's an example of the Netflix homepage. This exact same site on a different account with a different image, and yet another one, different account, different image. Now, a moment ago, I talked about how much bandwidth we use, and that's a topic that fills us with mixed pride, right? Because on the one hand, we're happy that you guys really enjoy the service. You watch over 150 million hours of television every single day, so you're really liking the content. But on the other hand, we don't want to take up the bandwidth, right? And we want to service our customers who have less bandwidth in more developing countries. So how do we do that? One of the things that we do is we learn, we experiment and we learn with our actual image encoding. So what is the optimal level of encoding and compression that we can do that's going to give you a high quality of experience? So there's a lot of things that go into this. We want to make sure that you've got good visibility on the eyes, on faces, but it's not just around your bandwidth, it's around the actual content that you're watching. And so you can see here 2 different images. And hopefully, you should be able to see a difference here, but it shouldn't be startling different, right? And the image on the lower right hand is a lot less bandwidth than the image on the top. Another thing that we do with our data is we use it to monitor our services. So we have, this right here is Flux. It's showing you a look at all of the traffic that is currently coming into all of our various web services. And there's little indicators in here that are red dots whenever there's failures. There's a lot of other intelligence that's happening in other places that are looking for issues, potential issues, and it's triggering automatic failovers, it's triggering alerting, it's triggering the things that we need in order to ensure that the service continues to be up. And then the last thing that I'll show you, these are just some of the things that we do with data. But this is actually one that I really enjoyed because this is something that I worked on. We use data to help our data engineers, and actually all of our users, try to tune their jobs. And so we want to give them context to say, this is something that we see as an optimization opportunity. Now, you don't care about all optimization opportunities, right? When do we care? We care when it's impactful and when it's recurring, right? So we give you the information, and then you know, hey, this job is inefficient and it's costing me an extra $1,000 a day. I should probably go take an hour to look at that. Or, hey, maybe this job's costing me an extra $500 a day, and yeah, I should take a look at that, but we're going to deprecate it in 2 weeks. So we're not making the decisions. We're giving our data engineers and our users the information and letting them make those informed decisions. So these are the users that I talked about that we serve from the data perspective, right, from the data platform. The users that I was specifically focused on were our data producers and our data insights, right? These are the people that were actively, directly working with the data platform. And my team's focus is, or was, on tooling that improved the overall usability of the platform. Again, trying to remove all the impediments so that people can do those really cool business things with the data. The challenge here is that this is a lot of different roles, and this is not even complete. And this is just a high-level glimpse. Not every role is created equal, and even within the same role, not all individuals or positions are created equal. So if you take data engineering, on the one end of the spectrum, we would have our content engineering team. And they're dealing with what we would consider small amounts of data. They have millions of rows, and they have different types of patterns. They have lots and lots of tables, and those tables might have some days you might have data written to it, other days you might not. You don't have consistent behavior because a lot of it gets triggered when somebody says, yes, let's go sign that title, right? So if nothing happens, it's actually completely normal for there to be no data. On the other end of the spectrum, we have our personalization team. They're the ones working with that trillion-row data set. And as you can imagine, they only have a handful of tables that they're working with. And they have a lot of anomaly detection because they have real high expectations around the amount of data that should be coming in every single moment, right? Our content team, they're data engineers, but they're working a lot with PySpark and Spark SQL. Our personalization engineers, they're also data engineers, but they're more closer to software engineers. They're writing their code in Scala, right, for performance reasons. So we need, as a platform team, to be able to create tooling that's going to support all of them, and yet, how can we serve all of them? So we had to really be smart about it. And the things that I look for, are, the 80% rule. Is this going to be working for 80% of our users for 80% of our use cases? And that really backs us into a very small number of tools when you think about it. One of them is Spark, right? Everybody, I think everybody except for maybe some of the scientists on this page would use Spark. But there's not a whole lot of other UI tools out there that they could use. Until we found Jupyter Notebooks. So how many of you have no idea what a Jupyter Notebook is? Okay. How many of you have actually used a Jupyter Notebook? Oh, cool. Awesome. Love that. Okay, so you guys already know. I'm not going to be selling you on this, but it's kind of hard to explain what a notebook is because it can really be just about anything. It is a single place that allows you to co-locate code in a variety of language, execute that code, get the data back, interact with that data, visualize it, work with rich media, annotate it, add comments, and share it out. Who is it ideal for? It's ideal for everybody working with data, right? Everybody working with data has come to love the notebook. But we didn't start off there. We started off with just our data scientists, and we wanted to make their lives easier. So again, from that platform perspective, we're trying to solve the usability of the platform. And we've got all data platforms are complex, right? All data is complex. And ours is even more so just because of the scale of it. And so our task was to try to obfuscate that complexity as much as possible. So we built an infrastructure to support that. And it was built around Interact. So Interact is just another front end for visualizing Jupyter Notebooks. It's also an open source project that has other packages or other components that can extend the Jupyter ecosystem. Everything I'm about to show you, almost everything here is open source, and it's pluggable, meaning you don't need to use every single piece that I'm showing you. You can pick and choose the pieces that are useful for you and throw away the rest. That was very intentional for us as we were building this. So we have Interact, and our users today will go to our big data portal, and they'll launch a notebook in which we'll launch the Interact UI. Behind the scenes, we're launching a Titus container, but it could be any other container management system out there. It could be Docker, Kubernetes. But we launched that container on their behalf, and we've created an image that has all of the tools that they need to do their job. We've also created a variety of, I would say, like data warehousing services that do other obfuscation for us, like Metacat, which is a federated data catalog. And then we have Genie, which is federated job execution. So when you hit execute on that job, that execution isn't really taking place inside of your container. It's taking place on like the Spark cluster, right? And so this is managing that workflow for you and also helping you get to the right data on S3 without having to know all of those weird URLs. If you were to log in, this is what it looks like. You just get this default setting. You don't have to change anything. You hit go, and it's going to launch that container for you. And then you're going to get an experience that looks something like this. Moving. So we built that out, and our users loved it. Our data scientists loved it. And they would pretty much live in a notebook all day long. But then they would find something, and it would be valuable, and they'd want to productionalize it. They'd want to put it out there. Or maybe they're not even sure if it's of value, but they just want to test it. And this is where you have to involve data engineering. And nobody wants to talk to data engineering, right? Not because they suck, but think about it, right? Like, data engineers are very valuable, and there's a point at which you want to involve them. It's when they can add value. That means that they have context on the data, on the technologies, they can help you scale. That's great to pull in data engineering. But what was happening was that our data scientists were writing something in R, and they needed it converted to Spark and to Python so that they could deploy it. And there's no value add there. I mean, our data scientists didn't like being roadblocked by our data engineers. Our data engineers did not like having to do that work because it's not fun. Nobody really liked it. And so we wanted to make it easy for them to schedule those notebooks. So we created Papermill. And Papermill allows us to think of notebooks as a template. And so you would create a notebook, which is your source notebook, and that notebook would have some parameters that you define, and you can inject those parameters at runtime. It will also create an immutable copy of that execution on S3. This was a game changer for us. This enabled a lot of things. It allowed us to schedule notebooks as a job. This right here is what that infrastructure looks like. In terms of the scheduler here, we've got Meson. Meson is just a scheduler. It's not open sourced yet, but we do talk about it publicly. You can plug and play any other scheduler. It could be Airflow or Cron or whatever you're using. But we were able to add that scheduling piece and run those notebooks in a headless state. And so that's what you see here at the bottom. And essentially, the rest of the architecture is the same. What this allows us to do is when we run that in the headless state, we now have a variety of different ways to trigger that notebook execution. We can do it through event-based triggers, which happen in Meson, which is an event-based scheduler. We can do it through time-based schedules, and we can do it on an ad hoc basis as a data scientist wanting to run one notebook with a whole bunch of different parameter sets, right? It turns out that this is actually very useful for data engineering. The artifacts that we were creating in our data scientist notebook, I mean, think about a data scientist, right? They're doing a lot of the same type of light data engineering work, right? But at the end of the day, they had this notebook, this immutable view of everything that executed with all of the parameters, all of the error logs, everything co-located in a single location. And I know you guys know how difficult it can be to try to troubleshoot a problem, right? And have to look and crawl through all those different logs. Here it is in one place. And if there's a failure, you launch that notebook and you hit run, and it's going to fail where the failure is, and you get to immediately launch into debugging. It is beautiful. And our data engineers loved it. So we decided that we were going to start doing more with data engineering through notebooks. So what this looks like is, this right here is our notebook template that we created. It is a Jupyter Notebook. And at the top of the notebook, we have a place for all of our different data platform settings, right? Things that are very important to the platform, but nobody else probably cares about them, right? But we need to have that information there to be able to change and control the environment. Then we have our actual data engineering script. Now this is something that lives on GitHub. Our data engineers are still working in IntelliJ or whatever tool that they're working with. They check that code into GitHub, but at execution time, that code gets injected into the notebook. We also have, as part of our ETL process, this concept of write, audit, publish, right? We do not want data to become visible to downstream consumers until we've evaluated the quality and ensured that everything looks good. So rather than have our data engineers touch their 10,000 ETL scripts that we have out there, we were able to just add that as another section to our notebook, and they could either choose to do something with it or they could choose not to, but it was there and it did not require a lot of re-engineering, which they loved. And then the final thing is the publish event, which says after we've done all of these checks, now we're ready for this to be to publish so that downstream consumers can see the data, but also our scheduler knows that that data exists and it can kick off other downstream jobs that are depending on it. Papermill is what we used for the settings for managing that. Spark is an example of what we use for all of our ETL. Our audits, if there was an issue, it would get triggered and written into our alerting service, and our publishing event took place in Mason. This worked extremely well. In fact, it worked so well that we converted all 10,000 jobs and 150,000 daily executions to run through notebooks. We've also modified all of our scheduling tools to be able to work with notebooks. So you can see here's an example of a job that was scheduled through Mason, and this is in our big data portal. So there was a failure, and you can see that we surfaced that error message right here inside of the app, and you can click on any of those links to go see exactly what it is, and you could even clone that notebook once you launch it. This was interesting, though, because this became an entry point for our data engineers to start working with notebooks. They really didn't need to work with notebooks just for us to do this, right? But having that notebook as a starting point for their debugging was really powerful. And we began to see them doing a whole lot of other things with their notebooks. They started doing more with their data quality checks. So here's an example of a notebook that this entire notebook is just for data quality. And this notebook could be scheduled on its own. It could be called from somewhere else. It could be called when there's a failure. And when there's a failure, it's going to run the notebook and it's going to email you the results. It's extremely powerful. And so we found that our data engineers began to do more with notebooks in terms of the data quality. But then what happened? They're like, hey, I like this. This is easy. I can write queries. I can get my visualizations without having to write any code. They began to do their initial data engineering discovery in there, their data quality assessments, their ad hoc queries, their troubleshooting and debugging. Increasingly, we found more and more data engineers doing that work in a notebook because it's easier. Here's another example of a notebook. Now, this is different. This is where we began to see not only our data engineers, but just software engineers writing full workflows inside of a notebook. Now, that might be making some of you cringe. I'm happy to discuss and debate that afterwards. But The end of the day, the goal here is enabling people to be able to easily work with data to accomplish a business goal. And that's what they're able to do. And so they can create these rather complex workflows, and they can handle the entire workflow inside of a notebook. And so instead of injecting ETL code into a notebook, we were scheduling notebooks themselves as the ETL. This is a look at our big data profile, our big data portal. And over the course of this, we started and we had our data scientists who had their sandbox notebooks, and then we had our data engineers and they had their notebooks for ETL. But then we began to see that people wanted to share notebooks. They wanted to share notebooks with their team, but beyond their team, and they wanted to publish notebooks as sources of information for their users. So our data engineers began to create notebooks that would encapsulate different types of tasks. It could be some cleanup, or it could be basically documentation. Here are our sample queries. Here's our data model. Here's what all of this information means. Here's how you work with these different things together. And they would publish a notebook, and that notebook would then become interactive documentation for our users, right? They were able to launch that notebook, and without having to really engage anybody, they could just start playing, right? So this has brought an even broader audience into notebooks. We've seen, again, more of our software engineers are using notebooks to document their Python APIs. We're seeing that we have our analysts that are using it to store all of their different ad hoc queries or different troubleshooting queries, and they publish it out there for everybody else to use. We're seeing our PMs that are putting all of their documentation inside of a notebook and sharing it out. So it's really gone far beyond what we expected it would, what it would be, but it's become a very powerful thing. All right, how am I on time? Good. Okay, so we have some time. I'm going to skip to a couple of other things to talk about. So this right here is a look at our experimentation solution. So I talked earlier about how we always want to test, and we're always constantly testing everything, essentially, right? But how do we do that? Well, in order to do it at scale, you have to build tooling around it. So here is a great visualization that we've built. This is a UI tool called Ablaze for A/B testing. That's why engineers should have named things. So we have Ablaze here, and it's a great visualization tool. And this is used by our software engineers, our data scientists, our PMs, our business leaders. Lots of different people look at this tool. But there comes that point in time in which you want to go deeper. You want to say, hey, I want to be able to explore this slightly differently, right? Right now, what was happening is that our UI team was having to go make changes, and they were trying to guess and hope that they were able to serve people's needs. But the reality is that it took a lot of time, and they really didn't meet every single need that people had. They could maybe help add for some of like the bulk things, but a lot of times when you get deep enough, it becomes very specialized. And so it's very difficult to create a one-size-fits-all UI for that. And so instead, what we've begun doing is with our other apps, you can actually integrate with notebooks, where you will create a notebook template, you will launch that notebook, and it will be pre-populated with queries from these other tools. What that allows us to do is two things. One, users can self-serve their needs a little bit better. And two, it saves our UI development resources. And actually, the third thing is it allows us to have our less technical users become more technical. So if you have a notebook and it's got a SQL query in it, well, at first it's very intimidating, right? SQL, ooh, I don't want to touch that. So they just ignore it, and they go straight down to the visualization, and they start interacting with it. And that's so great, but then they want to change it slightly. They want to see an additional field, they want to change a calculation, they want to change the aggregation or the predicate. And here's the thing, writing that from scratch, very hard. Giving them a starting point for them to modify becomes a lot easier. And so we've seen notebooks be a great way for our users, our actual analytics users, to self-serve their own needs. So with that, I'm going to, that's my talk. Thank you so much, and I'm happy to take answer any and all questions that you guys might have. And if you don't have time to ask a question now and you see me around the conference, please stop me, ask your question. I'm literally here for you guys, so I want to talk to you. Please find me afterwards.
I think we have some time to run through some Q&A on stage if you would like.
Yeah.
So if you don't mind, I'll read the answers or the questions, and you can supply the answers. So our challenges now with Jupyter is that it makes it very easy to ignore good coding practices. How do you enforce code quality standards and practices?
Great question. So I would say the first thing here is that we're not replacing our data engineering with a notebook. The data engineering practice, all of that work still takes place in the same way that it did before. It's only the execution of that code that takes place through the notebook. So whatever you had in place for your good coding standards should still apply. Once you get outside of that data engineering, I would ask you, does it really matter if you've got your data scientists who are not using best practices, right? A lot of times, they're just trying to do that ad hoc experimentation. And that point at which it becomes important, that point at which you should care about best practices and coding standards, that's the point at which you should implement them. Until then, everything else is just an impediment.
All right.
In my opinion.
Thank you for the question. Next question is, how do you version control with Jupyter Notebooks?
This is probably one of the biggest challenges with Jupyter Notebooks. What we've done is every time there's a change or every time you try to reschedule it, we create a new immutable copy of that notebook on S3. So we will have versioning there, but getting to it is a little bit more difficult. And so there's work that's being done in the Jupyter community right now that's working with Jupyter Labs and working with Interact and some of the other ones that are currently trying to create a standard definition of version control. Like, think about it. How do I define when that notebook has changed? Is it when there's a new comment added? Is it when there's a change to the actual annotations, change to the code has run, the data results have changed? So there's a lot of questions as to how do we think of a notebook version that have not yet been answered. So that work is currently going on.
Nice. The next question is, how do you connect data analysts and people who do business decisions? They just pass questions to the data team, or your team a particular analysis with decision maker?
So this is more of an...
sorry. Yeah, I think you got it.
I think this is more of an organizational question. And what we've done is we try to collocate all of our engineers, all of our business people together. So we would have, basically, if you take that three-tiered list of users that we have, we would create one of those for content, one for personalization, and it actually gets even more granular than that. You'd have one of those for like adult content, one for kids content, and so on and so forth. And because of that, there's a very close relationship between the business owners and the analysts. They know who each other are, they work with each other, they sit together. And so we circumvent a lot of that through that process.
Very nice. And what is the role of Tableau if you use notebooks that intensively?
Great question. And I don't want to misrepresent. I mean, notebooks have not replaced everything at Netflix. We've used them in ways that we were not expecting, and they've become more popular. They are today the most popular tool for working with data, but our most popular data visualization tool is still Tableau. So we have tons of Tableau out there. We're not replacing it. But what we have seen is that, yeah, some of our analysts are getting rid of their old Tableau report. I mean, if it was a pretty simple visualization, why even keep that around if you can get that visualization for free inside of a notebook? And so we've seen that transition take place, but we don't actually see it replacing, a traditional Tableau dashboard or report.
What is the size of the data organization, your team at Netflix?
So my team was around 13 engineers. We had about 108 engineers on our data platform, which, think about that number for a minute, because we don't own any infrastructure. So those 108 engineers are basically software engineers building out all of these services to support the organization. And then in terms of our data users, we probably have a couple hundred of our like data scientist-y type of people, maybe 50 algorithm engineers, ballpark. I will say, though, that Netflix as a company, though, only has about 5,000 employees. And so what we've seen, what I've observed is that we have a much higher percentage of people who are hired for a data-focused role than what you see at most other companies.
Very cool. And Wes is wondering, how do you promote reuse across notebooks? Do you simplify library creation or leverage notebooks as shared code? Is that a clear question to you?
I think so, yeah. I think I understand the concept of like shared code. I mean, we still have libraries. We would still, and once you get to the point where you want to reuse a function or something, we have shared platform libraries that those UDFs or whatever code should be promoted into. Again, the idea isn't that this notebook becomes a production mission critical place to actually write and as like your definitive source for all of your software. It's not meant to be that. It's more of a vehicle for the execution of it and then more of your ad hoc exploration.
And I guess many people are wondering if you're trying to add to those 5,000 employees here in Budapest.
We are unfortunately not located, Netflix is not located in Budapest. They are in Los Angeles and in Silicon Valley. Sorry.
Sigh. If you always look for my last interests, you will create kind of a bubble. How you fight against this information bubble?
Oh, so I'm assuming that you're talking here about the actual personalization algorithm?
Yes, I think
I cannot speak to that. That stuff is complex beyond my abilities. So what I can say is that they do try really hard to ensure that you're getting new content suggested to you that has broad appeal. So there's still things that say, it might not be something that you specifically are interested in, but you would see trending now. And so that might be one of the ways that they try to address that.
Maybe we can go through a few more, or whenever you're, okay.
I'm good.
How do you govern data users and data access?
How do we govern data users and access? Well, we have basically a secured environment, and then we have everything else. And the only stuff that really goes in the secured environment are really, really secure information, right? Anything that we don't think that should be broadly accessible. Pretty much everything else, stuff that still would be sensitive information around like company performance, all of that information is very accessible. We're able to do this in part because of the Netflix culture. So the culture is predicated upon this concept of freedom and responsibility. We are going to give you the freedom to do your job in whatever way you see fit, but you have the responsibility to actually be successful in doing that job. And in order for that concept to work, you can only hire senior experienced engineers. And so as part of that, like that, I think kind of helps with that problem where you have less junior people that are doing things they shouldn't. That's not really the case here so much. Separate from that, we have a whole bunch of security systems that are constantly monitoring activity. So we look for changes in behavior. Is somebody suddenly trying to dump down a whole bunch of data? Are they querying things they've never queried before? Is there anything suspicious about what they're doing? And if there is, then they go and shut down the access immediately, and then they go have a conversation.
Very cool. If you give full access to all your staff, how do you protect against your enthusiastic graduate BA from EG across joining your 3 biggest raw tables?
So I think we kind of answered that, but there's a little bit more to it, which is that we do have environment isolation. So there's an ad hoc query server, so your BA should never be able to affect your production jobs.
And how do you maintain the notebook environments? E.g., can a data scientist choose from a Python environment or create one?
Yeah, so we have a handful of environments that we've defined or predefined for our users. So there are all of the various Python variations and Spark variations, and we also have R and Scala. So we have each of those kernels, and within that we have our images that have all of our different services configured for them, all of the libraries installed, and then if they need something more than that, they have to install it themselves and include that in their script so that at execution time, that container has that software available.
And someone is wondering, for analytical scenarios, do you prefer Presto over Spark?
Presto, anytime you want something really quick and it's a smallish data set. But for anything, I would say like a lot of the ad hoc stuff I've seen has been done in Presto at Netflix. And then once you want to go to anything that's scheduled or recurring, or it's a large enough table or complex enough, then they move over to Spark.
And how do you manage knowledge coming from these notebooks and their discoverability?
I'm not sure about the managing the knowledge coming from notebooks part.
I think it's kind of like about knowledge sharing, like how these people are using their practices maybe.
So one of the things that we've done is that notebook could be shared with anybody. You take the URL and you can share it out. We also have Commuter, which is a view-only view of that notebook, and so that can get shared. Within the notebook, whenever I was left, we were working on a publish feature that would allow you to, from within the app, say publish, and at that point, it becomes discoverable. So we do try to separate this concept of being able to collaborate on a notebook or view it from this concept of publishing so that you can control, what's available to users. Most of the notebooks that people create, very few of them are something that they would want to publish.
And AJ's wondering, what do you do if there's an issue with the data? Do you just not write the data to downstream consumers until the data is fixed?
Yes. Yes. So if you think about data quality and like the perennial challenges with it, it's so difficult because there's no explicit indicator or signal that there's a data quality problem. So the best thing to do is when you do find a data quality problem, you stop everything. Like your downstream consumer almost always wants to know that there's a data problem rather than look at bad data. So if you think about that whole cycle, right? I've got data issues, but I'm not telling you, you're discovering it as a business user and you're coming back to me. I've lost confidence. I've lost your confidence. And now the next time you go to query that, you're going to ask in the back of your head, hey, is this data any good? And then if it happens again, then you're going to start saying it out loud. Hey, don't trust that system. It's not any good. If instead we stop our ETL and we say, we're going to notify our downstream consumers that there's a problem, they can understand that. And the business really shouldn't be making decisions based upon a day's worth of data. Like there is, at least like for our perspective, right? And so for us, the data quality would be kind of like a failure point at which downstream consumers could be notified of an upstream failure, but they wouldn't see the data flow through.
How is the flow of two data people working in the same notebook? How do you manage it?
It doesn't really happen. Two people don't really work in a data notebook together. I mean, people talk about it, but typically what happens is somebody has a problem with their notebook. They're trying to troubleshoot a data set, and so they'll shoot it over to somebody else and say, hey, do you know what's going on? That person will be in the notebook, and they might then just write some queries or something to be able to work with it. But this creates a problem where now whose notebook wins, and if there's changes, how do we save it? And so instead, we just found that we really don't have that. We don't really have that scenario happening too often. Typically what would happen is they would send an immutable copy, and then the user could clone it and then troubleshoot it and let them know. They can log into it where they're both doing it at the same time, but it's, like I said, it's primarily for troubleshooting or like early side-by-side programming type of projects.
Let's knock out two more questions and then leave something for people to discover afterwards.
Okay.
So I've heard you collaborated with AWS on EMR features. Do you still use EMR, and why/why not?
Ooh, honestly, I couldn't answer that. I'm not on that side of the data platform, so I don't know.
Too specific. How do you communicate insights or analyses broadly across the company?
That's going to happen on a case-by-case basis, but typically what would happen is at the end of analysis or at the end of some sort of project, there would be a memo that's written, and that memo becomes publicly available inside of the company for other people to read the work and to be able to comment on it.
And for the last one, what is the foremost skill you are looking for in your data insight people?
Data insight people. I would say, they're some of the hardest people to find, right? Because you need to find that perfect blend of you have enough technical skills to be able to hack at it, but you understand the business well enough. And so I think a lot of it is just about the ability to be persistent and to solve your own problems, right? If you have that troubleshooting mindset and you have a focus on the business problem you're trying to solve, then you're probably going to be successful.
All right, wonderful. Thank you very much.
Thank you.
Yeah, give a round of applause.